Okay, so first off, leave her hair alone. It's the first thing I've videoed is me saying leave her hair alone. God. Right, first of all, what's a function? So you may well have seen this notation, f of x. Yeah? Seen that function, that notation? That means a function is applied to x. Right? So basically, like Jen said, we've got some pluses, some multiplies, some divides and things, but you may well have seen, in fact I know you have because you've got a test on it tomorrow, linear functions. Alright? For instance, 2x plus 3 is a linear function. Yeah? So the general form of a linear equation, a linear function is mx plus c. So this would be the function. If I were to graph that, I would actually call it y equals mx plus c. There is no difference. It's just how we use it. So if I'm not intending to put it on a graph, I don't need the y value. All right? Yes?
Sorry, but if you have to give like a definition of like a function, like how would you word it?
So a function is a set of operations applied to x. So for instance, you may well have seen number machines before where we put x in. What happens to x? Well, we first off multiplied by 2, then you add 3, and you get a number out. Okay? Now, if I'm going to graph those two numbers together, I would call it y. This would be the function that is applied to x. So this is pronounced, this is read f of x. So that's
What stands for function of x?
the function of x. So I wasn't about to write that. The function that is applied to x. That's what f of x means. Okay. So you've seen them all before. So I could, if I were to have a second function written in my work, so let's say I'm doing a problem where I've got two functions, like you've been doing simultaneous equations. Well, let's say I'd written those as functions. So if I had a second function, I wouldn't use another f of x because that represents one function. So if I have a second one in the same piece of work, I might call it, anyone seen it?
fx1.
That could be one solution. That's not the one that was chosen. In fact, on your calculator it says y1, y2 because it's a bit basic, it needs something like that. But if we have a second function in the same piece of work, I would say g of x equals. If I have a third one, what do you think? H of x. Okay. Hey?
Oh, never mind.
If I have a function that's not applied to x but is applied to, so in physics you would have a function that's applied to distance, I could say f of d. Sorry, I didn't mean the t. F of d. So that would be a function that is applied to d, and instead of having 2x plus 3, I might have d squared plus 3d plus 1, for instance. So I might have a quadratic, but that's what that means. Yes?
Could you repeat what gx?
They're just a second function. If I'm doing a piece of work where I have more than one function and they're going together, all right, I can't call them all f of x. The reason is you'll often see in a piece of work, so in an exam question, so a possible exam question would be solve f of x equals g of x. Yeah? So if g of x was 5x minus 3, what I would be doing here would be 2x plus 3 equals 5x minus 3. That's what I would be solving. Which is basically doing what again? Simultaneous equations. Finding where two straight lines cross, that would be simultaneous equations. So what would I expect you to be able to do now? Well, put it in your calculator, find where they cross, solve that like it is, write it as two simultaneous equations and do algebra. Draw the graphs yourself by hand, find where they cross. All of the above I would expect you to be able to do for that. So all this is at the moment is just notation. Right? So we just say f of x, and if we are putting it in a graph, so if in a graph, if we're graphing it, we would use y, because then we would want the x, y coordinates. If we're not worried about having a graph, we can just use f of x, g of x, and the reason is because I can write my maths now, and once I've stated what g of x and f of x are, I don't need to keep writing them out. I can just say solve f of x, solve f of 5, for instance, which is what we'll go to next. Right, so it's a mathematical written shortcut. Right, bit shorthand where we can say we don't have, if you're going to get really long equations, we don't have to keep writing them, we can just use the function notation. We specify them once at the beginning and so on. Alright? Does that make sense at the moment? So it's just f of x, g of x, h of x. Make sense? Okay. So a couple of things we need to go through then, just with function notation, which is, if I said to you, evaluate f of 3. So we'll use the f of x equals 2x plus 3. If I said evaluate f of 3, what do you think you'd do?
You'd substitute x as 3.
Yeah. So this is doing substitute 3 into x. So therefore, f of 3 is 2 times 3 plus 3. Okay. So then we've got f of 3 would equal 9. Do you notice the word evaluate? Give a value to. Okay. Yes?
Sorry, but why is 3 going to where x was?
Because remember the general for we do f of x, so instead of the x I have a 3. So that means I'm substituting,
Just any number?
no, 3. So if I wanted to do, if I wanted to do f of minus 2, I would be doing 2 times minus 2 plus 3.
So is the substitute 3 into x part of the question?
No, that's how you'd have to know to do that. The question would be evaluate f of 3. Yeah, that's it. That would be the question.
So wait, how did you know to choose?
Because I gave you f of x, right? I'm asking you for a value for f of 3, which means you have to put 3 where x is in f of x.
So is the 3 part of the question?
Yes.
Because see, it's bracket x, and the 3 is where x is.
Oh, so that little part in the corner is part of it. Okay. Thank you.
Yes.
So the finishing answer would be f3 equals 9.
Yes. And what about this one? So f of minus 2 would equal?
Minus 1.
Negative 1.
Okay, negative 1. All right. Make sense? So it's just substitution. So that's what this bit is, isn't it? If I say, if I want a value going in, we are doing substituting. So with equations, there's either substitution or solving. So again, if I said now solve f of x equals, I'm going to give a random number, I might make it tricky, 7. What does that mean? So we know we have to do something different because I say solve rather than evaluate. But it's the way it's written then. So we've still got f of x equals 2x plus 3. So this is where that f of x equals 2x plus 3 would begin at the beginning of a question, and all I then have to write is what's f of 3, what's f of minus 2, what is f of x equals 7. I don't have to keep writing f of x is 2x plus 3. I'm doing it now because we're scrolling down the page. But what do you think we do here then, Ali?
The 7 replaces the fx entirely because it equals that.
Exactly, yeah. So if I know f of x is this, it's like the simultaneous equations thing again. If f of x equals 7 and f of x equals 2x plus 3, I can kind of put those things together and say, well, 2x plus 3 has to equal 7. All right? So if I solve it, I'm asking, when we solve, we're saying, what is x? We're doing the opposite. Yeah? And this kind of leads us where we need to go next. What's the answer, by the way?
2.
How do I find it? Inverse, okay. Do what first?
Minus 3 on both sides.
Minus 3 gives me 2x equals 4.
And then divide by 2 on both sides.
Divide by 2, and we get x equals 2. Yes, Ali?
So what's the difference between evaluate and solve?
Because if I evaluate, I just want to give it a value, so I substitute something in. So I could say, it's like calculate, evaluate. So evaluate means give something a value. All right? If I'm asked to solve the equation, I've got an equation, it already has a value. What's the value?
2.
Nope.
7.
7.
Oh.
The value is 7, and I'm being asked to find the value of x that goes in. Okay? So I'm kind of doing the opposite, isn't it? So evaluate means give something a value. If I'm asked to solve it, it means it's already been given a value, but I don't know what the first number was. Yeah? Make sense to everyone? Okay. This is the focus then, this whole solving thing. I want us to focus on this. Alright? Now, this might take a couple of moments to think through. And I'm just going to write something and see whether you can understand what I've done. Alright? You can have a little discussion and see what you think I've done. So, based on this that I've just written, so you've got it in your page, so I can scroll up, right? So I'm going to say this. If f of x equals 7, okay, okay. What do you think? What do you think I've done there? Yeah.
Is it a formula? Because, like, would it be 1 over f?
Okay, so let me, I expect you to say that. That minus 1 there is not f to the power of minus 1. It looks like it is, but it's not. It's just notation. It's all right. So in your laws of indices, to the power of minus 1 means 1 over it, doesn't it? And it's similar, but it's not quite like that. Yes.
Does f to the minus, not to the power, but like the minus?
Yeah, f to the minus 1 of, yeah.
The inverse of like the reciprocal kind of thing. It's not like, it's just like instead of x, it's y now. Instead of y, it's x now.
Okay, yeah. So, f to the minus 1 of x is the inverse of f of x. Okay. It's just the inverse function. So this is the, and you can tell that because if I know f of x is 7, I'm basically saying that x goes into the function of x and what comes out is 7. Now the inverse function is saying that if I put 7 into the inverse function, I get the answer 2, which that's, I know by doing it, I know that's what I had to put into the function. Does that make sense? So it's the inverse function. So that's what that notation means. F to the minus 1 means it's the inverse function.
So it doesn't change anything?
What do you mean by doesn't change anything?
No. Wait.
So I'm going to give a different function. So if I say g of x equals no, I don't want to use 2. Why do I use 2 all the time? 5x minus 1. Okay, so I've given you a new function now. All right. If I said to you, evaluate g of 3, tell me what you do. Okay.
You put 3 in for x, so it's 15. Oh, yeah. 15 minus 1.
That's me, excuse me. Gone, so 15 minus 1 is 14. Okay. How do we write something using our inverse function notation then? But no.
Does a g to negative 1 bracket 14?
Yep, spot on. Well done.
Wait, so would that mean for the 7 one, it would be f minus 1 bracket 2 equals 7?
No, because over here, look, f of 2 equals 7. That's what we did to start with.
Other way around.
Yeah, so we're doing the inverse, aren't we? And the inverse is kind of the opposite stuff, yeah? So basically, if we know what the answer is for the function, we then do the opposite way round. So basically then this is solving g of x. So if we apply the inverse function, we're actually solving g of x. Yeah? So it's important for you to keep that in mind. We're solving g of x when we do the inverse. Okay. Yes?
Never mind.
You go on. Someone else might want the answer.
I was just saying, like, why do you need the first part, like the gx equals 5x minus 1? You don't.
Well, because I worked out 14. Remember, I don't need it at this stage. I'm just explaining to you what it all means.
Okay.
Okay?
Wait. So, why would it automatically be? So,
Let me write it in a different way. Normally, I've written it like this already by now. write it in a slightly different way. So if I put x into f of x, I get an answer out. Notice how I'm not calling it y at the moment. I'm not writing y just because I'm not putting anything into a graph at this stage. So what do we do? So if I do this direction, I am substituting into f of x. Yeah? You happy with that? However, if I go the other way, I am solving f of x equals that answer. I'm trying to find the x value. Does that make sense? So if we do the reverse, we're solving for x.
When we say reverse, does that mean we can also say inverse?
Yeah, so I would prefer you to say inverse actually. So we're doing substituting one way, when you put x in and find the answer, or evaluating, and we're solving when we go the other way round. But another way to think of it, which is what you've always been doing anyway, is we do question mark and we go back and we say the inverse function of whatever I had will give me my x value. So I'm doing solving. So we can say that, and this is an important one because I often do this in an exam question and not many people spot it. And it comes up at IGCSE level, it comes up again, doing SL Maths, just done function notation stuff again, inverse functions again in SL Maths, and they ask the same sort of questions. Hopefully you will remember that solving f of x equals the question mark is the same thing as evaluating, okay, f to the minus 1 of question mark.
So that way is the inverse, and that way is the inverse.
The inverse.
You know the other one, just the regular one.
The function. So you've got a
Okay.
function and you've got its inverse. Yeah? So it's nothing different than you've already been doing, but it's just having different notation for it. Yes?
So wait, what's the difference between solving and evaluating?
They're considered the same thing.
No.
Oh, then why are they
They're the opposite, aren't they? Right, so if I'm solving f of x, I'm trying to find the value of x that would give me that value. Yeah? You'll get it in a bit.
Okay.
So
Wait, say it again, sorry?
if you solve something, you're trying to find the x value that will go in and give the value that you know it has. So if you go back up here, for instance, do you remember I said if I want to evaluate f of 3, I'm putting 3 into x and I'm working out its value. All right?
So this
So-
time we're trying to find it. Wait,
So
what?
if I were to then ask you for, well, how would I write the inverse of this? Write it in a different way. So I know f of 3 is 9. I would be saying that f to the minus 1 of 9 equals 3.
But how come that didn't work when I said the 7 and the 2? Because further down,
It's got nothing to do with bigger numbers.
further here, I said if I put, so.
Because remember, it's f of x and the inverse function of x. If you'd have said put 7 into the inverse, but that's not what you said at the time.
I'm sorry, I said it for the g for one, so I said if I do g regular bracket 3, will it equal 14?
Yeah,
So
g of
then
3 equals 14.
G negative is 1. Okay.
So the inverse of g of 14 is 3.
It looks better for the 3.
Yes.
I was wondering, for it to be G, you said that it's like that's the second.
Yeah, so I've just, because I've been using f of x a lot,
Okay.
I wanted to give you a new function.
Yeah, I was just wondering, was there something before that since it was G, but it is the time.
No, I've just decided to use g of x this time. I could use h of x next time.
Can
Yeah.
you scroll down a bit?
Wait,
Is
so
the arrow going that way for the f minus x? So
The arrow's
substituting? No, the arrow going on the top.
Well, it depends, doesn't it? Right, so the arrow is going this way all the time. Now you can either say that is solving f of x or substituting into the inverse function of x. Maybe it will help you if I do it in terms of the actual functions. Right, so
What's the top arrow for the green, for the F?
Solving. No, so that's substituting, isn't it? You're substituting into f of
It's
x.
still substituting?
Right, so let me do this one then. So if I say to you, h of x equals 3x minus 5. So I'm just sticking with linear at the moment to keep it easier. All right. What I'm going to ask you for is how do we find the inverse function? What is the inverse function? Yes.
We first solve that one, and then
Right, so I've nothing to solve at the moment, but it is, yes, it is the same thing as doing the solving mechanism, yes. So what would that be then?
so then you would put in a value. Does that matter?
Well, that might help you, right? But basically what we do, so like Haley's saying, if the inverse function is like doing the solving, well, if I were to say, well, give it a value and figure out what I was going to do, that's basically it, okay? So what we're going to do, though, is we are going to make x the subject. All right? So that, have you realised that's what solving's doing? X equals. So you know when you're rearranging formulae to make something else the subject? That's all you're doing when you're solving. You're making x the subject. When it's all numbers, you can simplify it all down to x equals 3 or something. But when we don't have just numbers, all right, we just have to leave it as whatever comes up. So we're going to make x the subject. Now, this is where I'm going to reintroduce the y to help us.
Is there a reason that that's F minus X not H?
Oh, sorry, no, it should be h. Right, I'm not focusing. That should be h. Right, sorry. Right, now I'm going to reintroduce, because it helps me, I'm going to use y equals 3x minus 5. So, what I'm going to do is I'm going to rearrange it to make x the subject now. So y would normally be a value, yeah, if I was going to solve, but this time I haven't got a value, I just want to know what the inverse function would be. So I rearrange it to make x the subject. So how do I do that?
Add 2.
No,
Add 5.
add 5 first. So I've got y add 5 equals 3x.
Then divided by 3.
Then divide through by 3 gives me y plus 5 over 3 equals x. Okay? So that's basically what you would have been doing. If I'd have had a value for y, I would have done that to find out what the x value is, wouldn't it? That's what you'd have done to solve it. Yeah? Does that make sense? So, for instance, just to hopefully make it real for you, if I were to say solve h of x equals 1, what would you have done? You'd have said 3x minus 5 equals 1. I've written it this way round because it's the same as your y equals. What do you do next? Add the 5, so you've got 6 is 3x. Then you divide by 3, so you get x equals 2.
So did you just choose 1?
Pardon?
You
Well, you won't bother putting a number in. I've just done it to show you it's the same thing. All right? What we actually want is the inverse function. Now, the inverse function is this. Okay? This is my inverse function. However, there's one final step that I've got to do. All right? And the final step we do is, and this is quite an important stage for understanding things later on, I'm going to swap my x and y around. Okay? Because we normally do x is the input, y is the output. And if we want to think of my inverse function as a function in its own right, we want to put x in. Now you notice it's h to the minus 1, the inverse function of x. So what I do, keep this in mind, because when we do the graphing stuff in a bit, all right, you'll understand why hopefully. We're going to swap x and y. And it becomes y equals x plus 5 over 3. And that is your inverse function.
Wait, I thought when you were allowed to like move things around there.
I haven't moved anything.
You said it.
Right, okay, let me use better language then. I've not moved. Alright? I've not just picked up the y and moved it to where the x is. I have changed the x into a y. I've renamed it, if you like. So the input value I want to call as x. Now the reason is, I put x, if I use the function, I put x in, I get a y value out. If I use the inverse function, right, I think like you said at the beginning, Hayley, it would be h of y would give me the x value. But we want to use normal notation. We want to say, well, the inverse function is a function for itself, so I actually want to put a number that I use x for into it. So I just, instead of calling it y, I call it x now. It becomes my new input. Does that make any sense to you? Right? So if I go back to this diagram here, it's basically doing this. X goes into f of x, and out comes y. Don't write anything at the moment, just focus on what I'm doing. X goes into f of x, out comes the y value. Alright? What goes in? Well, y would go in to give x back, but we don't want to write it like that. So what we say is, instead of that, we then say, well, I'm not going to call that y anymore. I'm going to call it the x value. And then I can say it's f to the minus 1 of x, and what comes out is a y. So it's now a function in its own right. However, the x value that goes into f of x is the same thing as the y value that comes out of the inverse function. So I'm not swapping x's and y's, I'm just renaming them. So maybe I should have used a better word. Does that make sense to you?
I'm just confused why we're allowed to rename this. Because I feel like if I were to rename things any other time, I would get in trouble.
You never get in trouble. You might do things incorrect. I've never said about you're not allowed to rename something.
But like,
No one's ever said that to you.
if I was doing that, and I was like, okay, no, this isn't going to work for me, I'm just going to rename this all the time.
But there's a very important thing. If I were to rename G H,
It would still work.
okay, I'd have to replace all the G's with H's. However, the problem that you would come up with is that the G and the H are not necessarily the same, so I couldn't rename it the same as something before. So the impact here is, if I rename my x, my y the x, then the x has to be renamed as well. I can't have them both as x's.
But for example, if I did that on that,
Yeah.
so it has the
I can change the P to be an A.
no, but if I have the 2Q and the 3P,
Yeah.
and I switch it so that's a P and then
Yes, but I'd have to change all the P's and all the Q's. You can recall the P's or Q's if you like, but all the Q's have to become something else. No? There's nothing wrong with doing this.
what's the point?
I can do that. Doesn't change anything. As long as when I'm being asked to input a P or a Q, I now say actually I'm inputting an A or a B instead. I've used a different thing. But what I couldn't do, I can't change it and say, well, I'm only going to change the q to a p, because that would make it p squared, which, you know, would be wrong. What you're thinking of doing, which what you said here was, you're picking up your x and y and just moving them around. That you're not allowed to do. I've not done that. I've just renamed them a different letter, which you are allowed to do.
Technically, the first y, so the y that has plus 5 next to it,
Yeah.
is that technically x plus 5? Like,
Well, it will be now, won't it? For my inverse function. Sorry, Jasmine, another question.
I'm confused. Why did we rename the x and the y?
Because I want to have, you always have x as the input, all right? The function applied to x. So let me maybe put it slightly differently for you, all right? Slightly differently. Put it this way. If I have f of x equals, let's do 3x plus 2, all right? What is the inverse function? I'm going to leave the bracket blank for, okay. What would we do?
x subject.
Make x a subject. So let's do it then. So I've got y equals 3x plus 2, so it becomes y minus 2 all divided by 3 equals x. Right.
X subtract 2.
Over 3 equals 1.
Pardon? Right, before, well, let's not swap yet, because I think a couple of people are struggling a little bit with
I
this.
don't know why we swap it, but we just
Right.
swap it.
Now,
Yeah, just
okay,
do it.
well, I'm trying to explain. Don't get into your own little thing. So, we've just got to think, how do we write that then? Okay? So, we could say, I guess, that to link the two, right, I could say, well, I'm going to apply a different function, so g, but I'm going to apply it to the y value, and I get x out, yeah? So g of y would be y minus 2 over 3.
Why?
Because that's what you're telling me. You don't want to swap the x and y, but it's a different function now, isn't it? I've got to take,
Oh, I see why we.
put the x, y comes out. If you want to stick with y goes in and x comes out, then I need to apply a different function, right?
Oh, because in the normal ones we have 2 x's.
Because the fx actually equals.
So I actually want to write an inverse function. So the inverse function, all right? So instead of having a separate function applied to the y, what I'm saying is the inverse function that is applied to the x is x minus 2 over 3. So what I then say is, well, instead of just saying put your y in, go back, you get the x, that's basically what you're doing. All I'm saying is, well, I want it to be its own function. I want, just because it happens to be the inverse function of f of x, it still needs to be its own function. And what goes into a function? So x goes in, f of x comes out, oh, sorry, y comes out. To go back, I still want to say x goes in, but I apply the inverse function. Sorry, my notation is going all over the place. Right. Okay, and I get the y value out. But it just so happens that this y value is the same as this x. It's just, it's a difficult one. You're screwing up your face and you just need to concentrate on it. It's difficult to explain because what you've got is a block in your head of, I don't know why. All right?
Why?
Normally, people just go, okay.
I
Right.
got it until you circled the y, then I got confused again.
Yes, Naila.
I know this might not be right, but is it like? Am I wait? Okay. So you know how fx actually equals y, like it's known as y.
Yes.
Okay. So it would just be weird if we had two y's on either side because, right? So don't have the y on that. I don't.
I can understand the problem.
I get what you're saying.
Yeah.
It basically is this, right? It's a matter of notation, really. It basically is saying, all right, I'm drawing the same diagrams again. Go back up here, all right? Do it again, all right? It's about a function can be an inverse function, but it also needs to be its own function, right? X, this one, x plus 5 over 3 is a function in its own right. X goes in, y comes out. Make sense? If you were to forget that that and that were the inverse of each other, all right, it has to be its own function. And notation states that the input value that goes in, if we're going to draw the graphs, is x. X goes into a function if we're drawing graphs. What comes out?
X, Y.
Y. Okay. X goes in, y comes out. Okay. Now, if you think of everything as its own function, right? So let me maybe try something a little bit different. So if f of x equals 3x minus 5, g of x is x squared plus 2. I'm going to add something different. H of x is x plus 5 over 3. J of x equals, what shall I say? Okay. Okay. What can we say? So I've got 4 individual separate functions. All right? I'm sure you've spotted what I've done. Okay? Because they are 4 separate functions in their own right, we can graph them all. But what I do know is that f of x links up with h of x. Why? It's the inverse. Okay? So, right, if I said the inverse function of this is actually the same thing as h of x. All right? So what we do is, because we've got x's in there, we have to say it's the inverse function of x. Now, all that means is that if I put an x value in to the inverse function, I will get, it will be like putting y back into this function and solving it. All right. What do you notice about this one as well? So this, oh, wrong one. This one here is linked with this one here, isn't it? Yeah. Okay. So we can say that the inverse function of g is the same thing as j of x.
But the 2 doesn't have a square on it, so how is it square root?
Well, you have to think how you get there. We'll have to go through that next time. Now, right.